Motion. Introduction. We often perceive an object to be in motion when its position changes with time. However, there are situations where the motion is inferred through indirect evidences. An object may appear to be moving for one person and stationary for some others. Most motions are complex. Some objects may move in a straight line, others may take a circular path. Some may rotate, and a few others may vibrate. There may be situations involving a combination of these. Uniform motion. Consider an object moving along a straight line. Let it travel 5 meters in the first second, 5 meters more in the second second, 5 meters in the third second, and 5 meters in the fourth second. In this case, the object covers 5 meters in each second. As the object covers equal distances in equal intervals of time, it is said to be in uniform motion. The time interval in this motion should be small. Non-uniform motion. In our day-to-day life, we come across motions where they cover unequal distances in equal intervals of time. For example, when a car is moving on a crowded street or a person is jogging in a park. These are some instances of non-uniform motion. Speed with direction. When the velocity of the object changes at a uniform rate, then average velocity is given by the arithmetic mean of initial velocity and final velocity for a given period of time. That is, average velocity is equal to initial velocity plus final velocity divided by 2. Mathematically, V average is equal to U plus V by 2, where V average is the average velocity, U is the initial velocity, and V is the final velocity of the object. Speed and velocity have the same units, that is, m, s to the power of -1 or m by s. Distance. Time graphs. The change in the position of an object with time can be represented on the distance time graph adopting a convenient scale of choice. In this graph, time is taken along the x-axis and distance is taken along the y-axis. Distance-time graphs can be employed under various conditions where objects move with uniform speed, non-uniform speed, remain at rest, etc. Velocity time graphs. In this graph, time is represented along the x-axis and the velocity is represented along the y-axis. If the object moves at uniform velocity, the height of its velocity time graph will not change with time. It will be a straight line parallel to the x-axis. Equations of motion. Equations of motion are V is equal to U plus AT. First, S is equal to UT plus half of AT squared. Second, 2AS is equal to V squared minus U squared. Third, where U is the initial velocity of the object which moves with uniform acceleration A for time t. V is the final velocity, and S is the distance traveled by the object in time t. Equation 1 describes the velocity-time relation